Hello and welcome to Ramble Time with me. Today I am looking at question 7.1 from the paper 1 of November 2022 from the department. And yeah, differentiating from first principles is not, I've never seen it like used in a, bizarre way, but I did just maybe want to have, at least one video showing, the gist of how it works. And when I saw an expression in this particular exam where you have x showing up twice in the expression, that does tend to make the differentiation a bit more hairy. So I thought maybe this will be a good one to kind of get into, but not because it's in any way like bizarrely different to what normally gets asked for first principles. Anyway, so differentiating using first principles is pretty much using the definition of f prime x, which is the limit as h approaches 0 of f of x plus h minus f of x divided by h, right? So this is pretty much something you've probably seen in your calculus studies. The idea is that we want to figure out what is the gradient of, or we want a function that will help us figure out what is the gradient of the graph at this exact point. But of course we can't have, a point doesn't have a gradient, right? The gradient is inherently, just by nature of what gradient is, it's talking about a line, a segment. But because a curve is not a straight line, that gradient is not going to be constant throughout the curve, right? So what we then settle for is this interesting expression over here where pretty much, okay, it starts out as I'm going to take these 2 points on the graph and join them, right? And that will give me, then I can figure out the gradient of that line, and that will give me a sense of the behavior of the graph's, the curve's gradient between these 2 points. But obviously that isn't accurate. So the way that we try to make it a bit more accurate is we try to move these 2 points, or one of them, closer to the other. So if this is x, right, and this is x plus some distance h, what we're trying to do is we're trying to get this distance as small as possible, right? So this is where this limit is coming in. We're trying to make that plus h tiny, 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 tiny. And what we're then doing is we're taking the y coordinate of this point, right, f of x plus h, minus the y coordinate of this guy, and dividing it by the change in the x's, right? To go from x to x plus h, we've moved by h units. So this is your straight line gradient calculation pretty much. But the interesting bit is this limit, which makes this gap here as small as possible. It's like if I could get these 2 points as close as possible, what is the gradient of the line that joins them? Anyway, right. Okay, so let's hit it. So we need to figure out what is f of x plus h. So we're going to substitute x plus h into the function. So that'll be x plus h squared plus x plus h. And I am going to simplify this by first factoring out the common x plus h. So here we'll just be left with x plus h, and here we'll be left with 1. I don't know if this really makes life a better place, but anyway, I'm going to pretend it does. So this is x plus h plus 1. And then I'm going to multiply it out. Well, let's see if I need to. So f of x is just x squared plus x. Okay, yeah, I need to, because now if I just minus this from this, we're not really going anywhere. Whereas if I multiply it out, there's a hope that this might cancel out with some of the terms. So I'm just going to delete this actually. No, not duplicated. Okay. How do I do what I want to do, guys? How do I do? I just want to delete this, man. Okay, right, so this will be x squared plus xh plus x, and then times the h in, so that'll be hx, or xh, and then h squared, and h times 1 is h. So this ends up being x squared plus 2xh plus x plus h squared plus 1. Right, so now we can figure out what is f of x plus h minus f of x. So this will be x squared plus 2xh plus x plus h squared plus h minus x squared plus x, right, which is just f of x. Right, and so we have x squared minus x squared and x minus x. Oops. So this ends up just being 2xh plus h squared plus h. Okay, so now the next thing we can figure out is f of x plus h minus f of x over h is equal to 2xh plus h squared plus h over h. Right, if we then factor out the common h up there, we've got 2x plus h, oops, close that too soon, plus 1, and down here we have the h. And for, any h values that aren't 0, this will simplify to 2x plus h plus 1, right, if h is not equal to 0. So what that tells us is, okay, cool, f prime x, which is equal to the limit as h approaches 0 of this guy, which I wrote out before, but I'll write him out again, right, will be equal to the limit as h approaches 0 of 2x plus h plus 1, right, and so we don't have an h in this term, so this will just remain 2x. Then the limit as h approaches 0 of h will be 0, right? The closer h gets to 0, the closer h gets to 0, so this will just pretty much become 0, become a negligible term, and the closer h gets to 0, well, 1 will still just be 1. So the expression for f prime x will be 2x plus 1. And of course, you also know the shortcut for, finding the first derivative of a polynomial. So you can just double check yourself, right? So this will become 2x and this one will become 1, which is exactly what we got down here. But let's double check with the memo just for control. And we do indeed get 2x plus en. Perfecto.